So, you're thinking about getting a heat pump, but there's too many unknowns. How big is this heat pump going to be? Are your radiators going to be big enough? Do you need one heat pump or multiple? How much is your electricity bill going to be? Fortunately for you, your installer should be able to provide you with all of this information after just one calculation. This is called a heat loss calculation and is what we'll be focusing on today. A heat loss report done to a good standard should be able to give you a clear indication of the power required that your heat pump needs to be, your future estimated running costs with the heat pump system, and whether your current radiator system is suitable for a heat pump or what size your new radiators need to be. If you're getting a heat loss report done, the assessor will ask specific questions about how much insulation is in the property, as well as taking the dimensions of all the rooms. This insulation is then used to determine the U values. U value is a way to measure thermal transmittance, with a low U value meaning something is really well insulated and a high U value meaning something is poorly insulated. Often, homeowners might not know how well insulated their walls or their roof are. In this case, the assessor should look at when the property was built and assume everything is done to standard building regulations of that time. Then the design temperatures will be taken into account. The design temperatures for a heat loss calculation is crucial as it determines the temperature differential in the property. This is a difference between the outside and the inside air. The larger the temperature differential and the larger the difference means the higher the heat loss. And this makes sense if you think about it. Assuming you'll want to keep your living room at 21 degrees, if it's minus 10 degrees outside, you're going to be losing a lot more heat energy compared to when it's 15 degrees outside. In the UK, we have to follow the design criteria for MCS, which stands for the Microgeneration Certification Scheme. We have to follow this to ensure you're eligible for the government grant for heat pumps, which we spoke about on the most recent video. It is very important to match the MCS design guidelines to ensure that the application for the government grant is a smooth process. The outdoor design temperature is specific to the postcode of the property and is the temperature at which 99% of the time it's warmer than. So for example, in the southeast, that figure is minus 2 degrees. So 99% of the time on your average heating year, the temperature is going to be warmer than minus 2 degrees. For indoor design temperatures, MCS recommend 18 degrees for bedrooms, utilities, hallways, 21 degrees for living room, sitting rooms, and 22 degrees for bathrooms. Once all of this information is available, the assessor will be able to look at the dimensions of all the rooms, the U values based on the insulation, and the temperature differential based on the design temperatures. From this, you'll be able to determine the power requirements for the heat pumps, i.e. how much power in watts does the heat pump need to be to get the specific indoor design room temperatures at the outdoor design temperature. As an example, on the screen, you'll be able to see a snapshot of one of our heat loss reports. As you can see, the outdoor design temperature is set at minus 1.8 degrees, which is specific to the postcode, and the indoor design temperatures vary from room type. If we take the hall and stairs, for example, based on the insulation in that room and its dimensions, that hall and stairs requires 479 watts of power when it's minus 1.8 degrees outside to get it to 18 degrees. Consequently, the accumulation of all of the rooms is the total power required by the heat pump to get all the rooms to temperature on the coldest days of the year. It's designed for a worst case. Next column along is not dependent on the design temperatures, but is an estimation of how much heat is lost in each room throughout the whole year. Assuming you're keeping all your rooms warm throughout the year, you'll have to put the same amount of heat energy into the property as is lost, and that's the assumption of this report. Therefore, this is what will be used to estimate your running costs. This is something that is often missed out by assessors, so it's really important that you ask for the energy heat losses in kilowatt hours over the accumulation of the whole year. It's essential for estimating how much the system is going to cost you. Now, once you have the information on how much energy is lost through the property in kilowatt hours, you can use that to give you an estimation on how much the system is going to require in kilowatt hours of electricity. But that is dependent on the efficiency of the heat pump. Now, the efficiency of the heat pump varies from a number of different things. It varies from brand to brand of air source heat pumps. It varies of whether you're looking at air or ground source heat pumps. They have different efficiencies. But the largest determining factor is the flow temperature you have running through your central heating distribution system, so your radiators, your underfloor heating. The colder the water you have running through your radiators or your underfloor means that the heat pump has to work less, which means that your running costs will be lower and your efficiencies will be higher. This means that the size of your radiators, or the amount of pipes you can get in through your underfloor heating design, is really crucial in terms of heat pump efficiency. And you can actually use the heat loss survey to figure out what size is necessary dependent on your property. This is something that we'll be focusing on the next video. There's a lot to go into, and we want to make sure we go into it with a lot of detail. For now, I hope you enjoyed the video. If you found anything useful, be sure to like, share, and subscribe.